right, today you're going to learn how to combine like terms. You will be using this skill over and over throughout your math career. So what you want to make sure you know is that like terms have the same variables raised to the same power. So when you're looking for like terms, make sure they have these two things, both the same variable and the same power. To combine like terms, what you want to do is you add up the coefficients, and then you need to keep the variable or variables and the powers the same. One thing that you want to keep aware of is that you want to make sure you take the sign that's in front of the term, not after it. When you're combining and adding things together, always take the sign that's in front of the term. So let's look at some examples and see if we can get this to make sense. So simplify each expression. Let's look at the one on the left. So 5x plus 7 minus 2x plus 3. If I'm combining my like terms, first I need to figure out what are my like terms. So things that have the same variable and the same power. So for instance, these x's both have an x variable and an exponent that's invisible of 1. So 5x, I'm going to circle it, is a like term with, here we see this 2x, but it has a minus sign in front. So you need to make sure you keep that negative sign in front of the 2x. And what you're doing is you're adding up 5x and negative 2x. So when I combine 5x and negative 2x, I get 3x. Okay? I have some more like terms in this situation, or at least another like term here. I'm going to notice that, let's see if I can get a nice light bright color. I have this positive 7 here, and I have a positive 3. These are just both constant numbers here. I can add up 7 and 3, and that gives me 10. If I have 3x plus 10, I can't simplify that any further because those aren't like terms. So when I say simplify the expression, your final answer is 3x plus 10. Okay, let's try another one of these. Okay, so in the second problem, I'm going to look for my like terms again. So my y's, I have a 6y, and I have this positive y. All right, and hopefully you notice that y has an invisible coefficient in front of it. It's the same thing as 1y. So when I add 6y and 1y, I'm going to get 7y. And then again, I look for like terms. This 4 has a negative sign in front of it, so I'm going to have a negative 4, and this 8 has a negative sign in front of it, negative 8. Negative 4 and negative 8 is negative 12, and I usually write this as 7y minus 12. All right, let's see if you're ready to try one or two on your own. So why don't you see if you can get these? Pause the video, then come back and see if you were right. There's some things to watch out for in certain ones of these. All right, so again, I'm going to look for like terms. If I look at this, I've got negative 3a. It stands alone because there's no other term here that has a's in it. If I look for my b's, I see a negative 4b and a negative 3b. When I combine those, I get negative 7b. And then last, I have that 5. There's nothing really there to combine with it, so it's going to be alone. And I originally looked like I forgot to bring down that negative 3a. It's customary to leave this alphabetical. I would probably in a final form write negative 3a minus 7b plus 5. So see if you got that correct. And then the last one. So here we've got some like terms. If I try this 7w, it doesn't have any other like terms because there's nothing else with the same variable and the same power. It just has a power of 1, and the other ones are both squared. When I look at the other two terms here, I've got a positive 2w squared and a negative 6w squared. My rule says I add the coefficients, so 2 plus negative 6 is negative 4, and I keep the variable and the power the same, so I have negative 4w squared. Don't forget to bring down that 7w. And I've got 7w minus 4w squared, or mathematicians would love it if you write negative 4w squared plus 7w.